Let's finish off this module by looking at an example of creating complex Windows infrastructure on Google Cloud Platform. Typically, setting up an environment with highly available SQL Server deployments on premises would start with a purchase order and take many weeks to complete. On GCP, you'll be able to harness a Cloud Launcher solution, and with just a few clicks, you'll provision the entire end-to-end configuration. Mission-critical SQL Server workloads require support for high availability and disaster recovery. To achieve this, Google Cloud Platform supports Windows Server Failover Clustering, WSFC, and SQL Server Always-On Availability Groups. Always-On Availability Groups is SQL Server's flagship high-availability disaster recovery solution, allowing you to configure replicas for automatic failover in the case of failure. These replicas can be readable, allowing you to offload read workloads and backups. Compute Engine users can now configure always-on availability groups. This includes configuring replicas on virtual machines in different isolated zones, as described in this reference architecture. In this reference architecture, you'll need two custom subnetworks. Each will hold a SQL Server instance. We also need an Active Directory, as with most typical Windows workloads. We'll promote this domain controller to also be the DNS server. Both SQL Server nodes need to join the Active Directory and update their own DNS settings. When you build the WSFC and availability group using these two nodes, since we're using static IP addresses, the system will ask you to specify a cluster IP and listener IP addresses. We need to configure these using Google Compute Engine's advanced routing so that the packet can be forwarded to the appropriate node. This configuration offers regional high availability. While you could create two subnetworks in the same zone, this won't handle zone-level failure. We need two or more custom networks because the system is built on multi-site failover clustering. It also means that SQL clients need to support multi-subnet failover for the optimal failure time. When Google have tested this, it can usually complete failover within 15 seconds. When it comes to IP addresses, cloud networking is very different from the on-premises network environments you're used to. At a high level, Google Compute Engine networking is like a big layer 3 switch. DHCP and similar everyday features work differently from how you might expect based on your on-premise networking experience. Google Compute Engine networking doesn't know about cluster virtual IP addresses such as the SQL Server Availability Group listener. It won't automatically assign a new IP address to the VM. As we configured Compute Engine Advanced Routing, the listener IP address must, by definition, be outside of any Google Compute Engine network address range. However, from the perspective of Windows running inside the VM, it has to be in the same subnet range as the primary internal IP for the virtual machine. Here's a typical network configuration that Google recommends for use in this scenario. There are two subnets, 10.1.0.0/24 and 10.2.0.0/24. On the virtual machine side, the VM network configuration has a subnet mask as 255.255.0.0. So the virtual machine view of the network is a superset of the Google Compute Engine subnetwork view. When we pick up the listener IP address, we just need to pick up an address which is outside of the Compute Engine subnetwork, but inside the virtual machine's subnet mask. Look at listener's IP address 1 as an example. This is 10.1.1.5, which is outside of the Google Compute Engine subnet, but it's the same network as the internal IP address 10.1.0.4 from the virtual machine perspective.